Hello everyone. In this video, I'm going to share how to draw how to sketch the graph of cubic functions and hence determine its domain and range. For this discussion on the cubic function, I'm going to divide my videos into three parts. There are three videos. So later on, don't forget to stay tuned to my channel to view my second video and third video for the discussion of the cubic function. Let's look at the example 1. We have given the f(x) equals to 4x cubed, and the domain of the cubic function is given as x is from a -1 to 1. So let's see how to sketch this graph and determine the domain and range. To sketch this function for x cubed, I'm going to start with my basic function. The basic function for the cubic function, I will use y equals to x cubed. Okay, so y equals to x cubed is my basic function for the cubic. And now you can see that what is the difference between my basic function and the function given. From the basic function x cubed, I'm going to sketch for the y equals to 4x cubed. So the difference between the x cubed and 4x cubed is the coefficient of the x cubed. From the 1, coefficient 1, I have changed to 4. This makes the graph to be shrink down, meaning that the graph will be steeper compared to the y equals to x cubed. So when I sketch the graph will be the same shape as the y equals to x cubed, and it also will passes through the origin, and it go down faster compared to the y equals to x cubed. So as a conclusion, okay, y equals to 4x cubed will go up faster and going down also faster compared to the y equals to x cubed. So this we can label as a y equals to 4x cubed, and the basic function we can erase it off. Okay, after that, we know that this is the origin, and the domain, they want a domain from -1 to 1. So from the domain, from the x -1, I'm going to cut down the graph. I'm using the dense circle to show the graph has been cut off. And this for the 1 also, I will do the same. When the x equals to 1, I also will cut down the graph. And after that, I only will remain the graph in between -1 and 1. So I use the red color to highlight the graph that I want. Okay, including the dense circle. After that, the accessor graph, I will erase it off. Okay, so this is the graph that we want, that the domain is from -1 to 1. So the question asking for the domain we know that it's from -1 to 1. You always can present your domain in the interval form or in the set form. You just copy down the domain from the question and put it into the set form. This is the domain in the set form. And after that, we want to determine the range. The range, we will find the lowest value of the point. This is of the graph. The lowest point of the graph, will be this point, and its corresponding value of y is, when x equals to 1, we need to find it. When x equals to -1, you substitute into here. You get a -1 power of 3, that is -1. So multiply by 4, you got it -4. Okay, so this is -4, and when x equals to 1, substitute into here, you got the y equals to 4. Meaning that the domain, the range for the lowest point, okay, the range, you will search for the lowest point and find its corresponding value of y. So your range will start from -4, and after that it will end up at 4, because the highest point having the y value 4, meaning that your range will be end up by 4. And use the close bracket, because both endpoint, you can see I'm using the dense circle to show that the graph including the 0.14 and -14. For the function b, I've given -x cubed. So again, we will start from basic graph, that is a y equals to x cubed in this shape. To sketch this function, I'm using transformation approach to sketch the graph of -x cubed. So we have revise back the y equals the linear function. If we have y equals to x, Okay, this is the graph of y equals to x. It's a straight line, linear line like this. And if we want to sketch a y equals to negative x, we just reflect the graph about the x-axis. This is the x-axis. Reflect the graph, reflect the basic graph at the x-axis. We have this straight line, and you can name this as a negative x. Okay, so reflection happen when the function of y, okay, when the function of y multiplied by a negative. If you negative of the function of y, meaning that your graph of the original basic function, it will reflected about the x-axis. The same thing over here. If you have the basic function y equals to x cubed, now the function has been negative, has been multiplied by -1, meaning that from the y equals to x cubed become y equals to negative x cubed. So this graph will become like this when it reflected about the x-axis. Okay, this part when you reflect about the x-axis, you have this, and for this side, when it's reflected about the x-axis, you will have the shape like that. Okay, so now you can label this as a y equals to negative x cubed, or you also may label it as a y equals to fx, because the domain we are already settled it, because this for this function they just don't restrict the domain. Okay, so you can see that my graph, you can have two arrowhead over the endpoint to show that the graph is for this endpoint is going to the left and going upwards, and for this endpoint it going to the right and going downwards. So now you can just erase off the basic function. This is our new function, which I label it as a y equals to fx. In order to get the domain, if for any cubic function, if the question did not state the special condition for the domain always from the negative infinity to infinity. This also can be obtained by looking at your graph. You can see that the graph shows the arrowhead here. It shows the graph is going to the left, and this arrowhead shows the graph is going to the right non-stop. And in between the negative infinity to infinity, you can see the graph is just continuous. Okay, it won't cut, it won't break in the middle. So the domain, you can say that is from negative infinity to positive infinity, or you may say that the domain is from is all the real number. The x can take all the real number. For the range, the same thing. If the any cubic function, if the question did not restrict any range, any domain, then the range will be from negative infinity to infinity. Again, you can see this from the graph. The graph is going downwards and going upward without stop. Okay, so the y, you can also set write your range in the set form. Writing the y is all the element of the real number. So these two, the domain and the range, both of them having the value negative infinity to infinity for any cubic function without the restriction of the domain. For the function x cubed minus 1, I also will use a transformation approach to sketch this graph, and please note that the domain is only start from the 0 to infinity. Okay, so we start from the basic graph y equals to x cubed. This is the shape of the y equals to x cubed. And now I want to find x cubed minus 1, meaning that I will translate my graph, okay, downwards for 1 unit. Okay, or in other words, you can say that move your graph down for 1 unit. So from the origin, from this point, okay, at the origin, I will move my graph down for 1 unit, meaning that now this point will become -1, 0, -1. It will be over here. And now you can sketch your graph with the same shape as the x cube, but the point, or we said actually this is the point of inflection. Okay, and this point of inflection will go down for 1 unit. Now it will reaching the -1. Okay, so now you can erase off the basic graph and label this graph as a y equals to x cubed minus 1. But you haven't complete your task yet, because you haven't operate on the domain, because the domain they want from 0 to infinity. So I'm going to use my dance circle, because it includes 0, right? So start from the 0, here will be the point of x equals to 0. Start from the 0, I cut down my graph, okay, cut at the point x equals to 0, and since the domain they want x greater than 0, right, so we just will remain this part. Okay, and the rest of it we will erase it off. Okay, then after that you can you already settle the domain. You can actually label your graph as a y equals to fx. So this is the graph that you want, and from this graph we want to determine the domain and the range. For the domain, you can see it from the domain from the question given. This is the domain actually, okay, or you can see from the graph you get the point which is closest to the left. This is the point closest to the left, and it has a value x 0, so the domain will start from 0. You can see this is a dense circle, so it includes 0, and the arrow over here is the point, the end point over here shows that the graph is going to the right non-stop, so your domain will until infinity. All right, and the range is from the lowest point of the graph. The lowest point of the graph is this point, and it has the y value -1, meaning that your range start from -1. Since you see this dense circle, right, so this will be a close bracket, and this arrowhead shows that the graph is going up, okay, indefinitely, meaning that your range will be up to positive infinity. So this is your domain and the range from the graph. You may also find this point x-intercept, all right, by substituting the y equals to 0. When you solve x cubed minus 1 equals to 0, you will get it x equals to 1. So this point will be 1. For the function x plus 4 cubed, right, we also can use transformation method, yeah, to sketch the graph. Start from the y equals to x cubed graph. If we want to sketch x plus 4 cubed, right, from the x here, now the x become x plus 4, meaning that now your graph will either move to the left or move to the right. It depends on the sign here. If you see that the x, okay, x plus 4, the sign is positive 4, meaning that your graph will be moving to the left for 4 units. Moving to the left for 4 units. If you have x minus 4 cubed, meaning that your graph will be moving to the right for 4 units. Alright, if this sign is negative, meaning that moving to the right. If this is a positive, meaning that your graph is moving to the left. Start from the y equals to x cubed. This is the shape of the y equals to x cubed. Move your graph 4 units to the left because we have positive 4. So from the 0, 0, move 4 units, 1, 2, 3, 4. Okay, this will become negative 4. So now your graph will become like this. The shape will be still the same as a y equals to x cubed. It will become like this. And you can see that your graph will passes through the y-axis. Later on, you may find the y-intercept. Okay, then after that, you can put an arrowhead to show that the graph is going down and going up indefinitely. Now you can just erase this off and label the red line with your y equals to fx, because the fx, this function, the domain is the function don't state any special domain. The function didn't state any special domain here, so you will know that the domain is from negative infinity to positive infinity. This is a graph. All right, then to get the y-intercept, I can substitute the fx, the x equals to 0. Substitute this equals to 0, you got a 0 plus 4 cubed, and this value is actually 64. To get the domain, after we have done the graph, to get the domain, again, as I said, for any cubic function, if the special domain didn't state next to the function, meaning that the domain will always from negative infinity to positive infinity, and the range also will be the same from negative infinity to positive infinity. Okay, the interval you also can obtain by looking at the graph here. Okay, this two endpoints shows that the domain and the range is from negative infinity to infinity. For this function, x minus 1 cubed, the domain is allowed from 0 to 2. Yeah? To sketch the graph, I will use the transformation approach. Again, I start from the y equals to x cubed. This is the y equals to x cubed. And you can see that now the question asking for the x minus 1 cube. From the x, this one become the x minus 1. So we know that the graph is moving to the right. From the basic graph, we move our graph to the right side for 1 unit. This is the graph of x minus 1 cube. Alright, so now from the 0, 0 origin, I move 1 unit to the right. Let's say this is 1. And the shape still will be remain unchanged. This is the graph of a y equals to x minus 1 cube. And now we erase off the basic graph. You have this. After that, we must take care of the domain. The domain is from 0 to 2. So at the x equals to 0, I use my dense circle to cut the graph. And why I use dense circle? Because of the close bracket over here. And at the x equals to 2, the same thing. I will cut the graph. And I will remain only the graph from 0 to 2. The rest will be erased off. Now, I can highlight my graph 0 to 2 with my blue line and the dense circle as well. Then the excess, I will just erase. Okay, so this is the graph that we want, and we need to get its corresponding value of y. So when x equals to 2, you substitute inside, you get the y equals to 1. And when x equals to 0, the y will be equals to negative 1. So complete our graph, we can just label this graph as a y equals to fx. Now to get the domain, of the graph from the graph, I will have a domain from 0 to 2, which is I follow the question because the question already given. And the range of the function is the lowest point having the value of y negative 1. So the range will start from negative 1 up to the highest point of the graph having the value of y 1. So the range will end up by 1. And both we use the close bracket to show that these two endpoints is included in the function. For this function, I'm going to use transformation approach. Okay, one more time. And we must take care of the domain. The domain is from from negative infinity to negative 3 and not include the negative 3. First of all, we just sketch the graph. And to sketch this graph, first I will try to sketch the basic graph first. That is my y equals to x cubed. From my y equals to x cubed, I will try to sketch a y equals to x plus 4 cubed by moving my graph of the basic to the left for 4 units. And after that, I look at the function having the coefficient of 3. So now after this, we need to sketch the graph of 3 multiplied by x plus 4 cubed, which you will make this will make your graph of x plus 4 cubed to be more steeper. Okay. After that, we will take care of the constant over here. That is y equals to 3. We will sketch this graph minus 1. Taking the using the third graph, and then you shift down your graph for 1 unit. You will have 3x plus 4 cubed minus 1. That is your fx. So start with our y equals to x cubed with the shape. And now you need to sketch the second graph. This is the first, second, third, and fourth graph. Okay, so to continue with your second graph, we need to shift our graph 4 units to the left. You can see that the x become the x plus 4. As I said just now, if this is a positive 4, meaning that your graph need to be shifted to the left for 4 units. So shift your graph 4 units to the left. 1, 2, 3, 4, meaning that now your point of inflection at the origin here will become at the negative 4, 0. So your graph will look like this. Okay, now erase this off. So this is the graph. This is the graph of y equals to x plus 4 power of 3. After that, you need to sketch 3 multiplied by x plus 4 power of 3. Actually, you can use this graph to represent the third graph also, never mind, because the shape and everything will be the same, only that you will see that the graph now is a little bit steeper maybe. Okay, not a little, much more steeper because multiplied by 3. But the shape still will be the same. The shape still will be the same. And it also will pass us through the negative x equals to negative 4. Okay, so now you can erase this off and label your green line with your y equals to 3 x plus 4 power of 3. Alright, after this, you need to sketch the graph or function, which are 3x plus 4 cubed minus 1, meaning that now your point over here will go down for 1 unit. It will become over here. It will become negative 4, negative 1. So you can sketch the graph with the same steep, same gradient. Okay, but it go down for 1 unit. Alright, then you can now erase this off. You have your graph y equals to 3x plus 4 cubed minus 1. Alright, now we take care of this domain. The domain is want graph from negative infinity to negative 3. So negative 3 will be somewhere around here. This will be your negative 3. So at the negative 3, I will project a line down to my graph, and I use my empty circle to cut my graph because the domain state here does not include the negative 3. And they want the x is less than negative 3, right? So you will just remain the graph at the left hand side. Okay, this is your inflection point. And the rest of the graph, you will just erase off. You will have this. Okay, and the tail at this endpoint, you can put an arrowhead to show that the graph is going to the left and going downwards. You can now label this as your y equals to fx. And find the domain from this graph. Domain already given in the question actually is from negative infinity to negative 3 and not include the negative 3. And the range, search for the lowest point of the graph. This is the lowest point of the graph. Since this graph is going down without stop, so the range will start from negative infinity. And the highest point of the graph is this point. So when x equals to negative 3, you need to find its corresponding value of y. Substitute the negative 3 inside here. Put a negative 3 inside. You got 4 minus 3, 1. 1 cubed, that is 1. 1 multiplied by 3, 3. 3 minus 1 is 2. So this point should be 2. This point should be... This is just not making sense because the 2 is a positive number and it is impossible for my graph to fall. This point to fall under the x-axis. So I need to slightly adjust my graph, meaning that the graph, when x equals to negative 3, the graph need to be above the x-axis. Okay, so I will just erase this line. Okay, so this is my graph where this point is negative 3, x equals to negative 3. When x equals to negative 3, oh no, this is negative 3. I need to sketch my graph in this. Okay, so when x equals to negative 3, this is the point negative 3. When x equals to negative 3, I got my graph. Y value is equals to 2. Okay, so you might see that at the x equals to negative 3, I use an empty circle, okay, to cut down my graph. So this is negative 3, 2. Okay, when x equals to negative 3, you substitute negative 3 inside here, you got the y equals to 2, meaning that this is the correct graph. We should draw the graph, sketch the graph more steeper so that when x equals to negative 3, the graph is having the y value positive 2. Okay, so the range will be from negative infinity to the highest point. This is the highest point of the graph, and it has the value of the y2, meaning that our range will up to 2, and we should close it with the open bracket. For this example, this function is easy to use transformation approach to sketch the graph. Again, we'll start from our basic graph, that is y equals to x cubed. This is the shape, roughly the shape of the x cube. And later on, we are going to sketch a x minus 3 cube, which I will move my graph to the right for 3 units. After we have done this, I'm going to find a negative of the x minus 3 cube, which I will reflect this graph. The second graph, I will reflect it about the x-axis to have the negative graph. After that, we will move our graph 2 units upwards. Okay, then we will have our function of fx. Start from here. To sketch the x minus 3 cube, I'm going to move my graph 3 units, 1, 2, 3, to the right. Okay, I have this. Then erase off the basic graph. This is your y equals to x minus 3 cube. After that, taking the negative of x minus 3 cube, which I will reflect my graph about the x-axis. For this part, the right-hand part, I will reflect about the x-axis. You will form the graph in this shape, and the other side will form the graph in this shape. Okay, then after that, erase this off. So this is your graph of a negative x minus 3 cube. Now, to form the function fx, I need to translate my graph 2 units upwards, meaning that from this point, from the x-intercept here, I will move this point up for 2 units. From the 0, I will move up, that is 1, 2, this becomes 3, 2. Okay, this point will become 3, 2, and the same shape will be drawn. This is this side and the other side. And you can see that now my graph passes through the x-axis at another point. I need to find it later on. Now you can label this as a y equals to fx, since the domain, they just don't have any condition for the domain. So you can put the arrowhead at the end point to show that the graph is just going to the left and right and going up and down. Okay, so in the middle here, this inflection point will be 3, 2. So this point, how do we get it? We can let the y equals to 0. After we have solved this, we will have x equals to 4.26. Let the fx equals to 0. Solve for the equation. You got the x equals to 4.26. So this is your point of 4.26. In order to get the domain, again, as I said just now, if the cubic function, they did not state any special condition for the domain, meaning that the domain is always from negative infinity to positive infinity, and the same as the range. The range also from the negative infinity to infinity. This answer, this interval, you also can be obtained from the graph. You can see the 2 arrowheads shows that the graph is going to the left, going to the right non-stop, and also the same going down and going up without stop. So the domain and the range will both all the real number.